Okay, guys, today we're going to go over input and output, which is basically the ability to get input from the user, get them to type something in, and print stuff back out to the screen. So, admittedly, in most programming languages, we would not bother denoting a whole section to this. We would just be like, well, here's print statements, and here's, read statements, and that's all there really is to it. In Haskell, it's a bit more complicated. Now, the risk of upsetting true Haskell and functional programming fans, I'm just going to say it, it's annoyingly complicated, at least getting started, just learning how to do input and output in Haskell. It seems like it's been made unnecessarily complicated. However, learning how input and output works in Haskell is actually going to teach us a bunch about concepts in computer science that are actually very worth learning. So before we get into that, let's talk a bit about pure function. So don't worry, this is some preface to converting you into some weird functional programming cult. That'll come later. Pure functions are just functions that have two important properties. So really, this first one is really just the definition of what a pure function is. It's a function with no side effects. So this means that any function, whenever you give it an input, is going to give some output, and it will always give that same output for that same input. Okay, so it'll never have some scenario where you call the function on, say, an input 5 and then return 6, and then later on you call the function on an input 5 and it returns 7. That'll never ever happen. Okay, and this has a consequence that the function can be lazy. So this has to do with how the function gets evaluated. The idea is that nothing gets evaluated until it absolutely has to be. So a good way to understand pure functions is by looking at the inverse, impure functions. So impure functions allow side effects. Take, for example, this following bit of C code. So this bit of code, it has what we call a global variable counter here. So it's a global variable, meaning that it can be accessed outside of a individual function. So it's not inside of this function. It can be accessed by any number of functions. And inside of this function, we alter the value of the global variable. Now, the thing here is that, so that's what this plus plus does. It creates counter equals counter plus 1, and then it returns that value. The thing here is that every time we call this function, okay, with some value for its input, it's going to return a different output. So now let's take a look at an example of a pure function in Haskell, and let's highlight some important properties of this. So consider this first function, useless arithmetic. So useless arithmetic, it's going to compute some different multiplications here, okay? And you'll notice that the order, so if we were to evaluate this, we would end up at square 1 is going to be the first thing evaluated, okay, which just equals x. And then square 2 would then get evaluated because it needs square 1. And then square 3 then gets evaluated because it needs square 2. Now, the thing is, things will get evaluated in the order that they are needed, okay? So it's like square 1 will end up getting evaluated first because it's needed first, okay? Because you can't get to square 2 without square 1, and you can't get to square 3 without square 2. But besides that, the order doesn't matter. So if I were to switch this around and say put square 3 in the position of where square 2 was inside the let, it wouldn't make any difference. Okay, it would be the exact same piece of code. So in this way, evaluation it's derived by evaluating things when they are needed, not in the order that the programmer specifies them. Similarly, let's look at useless arithmetic 2 here. And we have two local variables, x and y. And y takes the sum of what's actually an infinite list. And then I call useless arithmetic on it with x as the two inputs. And I actually never ever use y. Because I never ever use y, it just never ever gets evaluated. So this is different than in a lot of languages where I would write this and the code would go through it, and by the time it gets to y, it decides to try and evaluate it. Okay? In Haskell, because it's never ever used, it just never gets evaluated. This is what I mean by lazy evaluation that I mentioned before. So now let's introduce you to your first IO function. This is one you've probably seen before, the print function. So if you type in print hello world into GHCI, it'll give you back hello world. No, this is a bit different than GHCI just regurgitating values, which is what we've been seeing before. So by default, whenever you enter something in to GHCI, it automatically kind of just calls print on it. Okay, so if you were to just write a function that returns hello world, it would automatically call print on it. But print is still very important for if you're making programs that are compiled and not just run through GHCI. If you are making a compiled program, then you need a main function and you need to attach your print statements to that main function. Let's take a look at how this works in VS Code. So let's make a function called print hello, okay? And let's say print hello is just equal to print hello world, okay? And you'll notice its type is IO and these two empty brackets. So these two empty brackets just mean nothing, is kind of what they represent. It's a little weird. They kind of, so you'll see later that we could return IOs of other types. But for now, whenever you like just print something to the screen or something, it's just an IO nothing. So print hello, let's say we save this and we open up the terminal and load this into GHCI. GHCI, of course, .hs. Okay, let's load this into GHCI and run print hello. And it shows hello world. And you'll notice this isn't much different than if we wrote a function string hello. So let's rewrote this. So as far as we can tell, this is like doing the exact same thing, but actually something different is going on. Okay, and it has to do with the fact that GHCI, no matter what you give it, it'll kind of just call print on it for you automatically. And you might be wondering, well, what is the point of the print statement in general? Well, most Haskell programs, we use GHCI to do development for debugging stuff. But at the end of the day, when you actually make a program, okay, some executables run, you're going to have to run things through the compiler and then use that executable. And that executable is going to use a main program. So if we switch our files here to main.hs, you'll notice that the main program is an IO. And it's going to be a sequence of these sorts of, anytime you want to print something, you're going to have to write print here, okay? It's not good enough to just put hello world here. You can see right away, this is an error. This isn't an IO type. So the main program is always going to be this IO empty thing, right? So you're basically always going to finish your main program printing something out like this, okay? So we print hello world, and actually since we're importing lib, we could just replace this with our function print hello here, okay? So you'll see, let's say we quit out of GHCI here, and let's do this the other way. Let's do a stack build. So we build an executable, and then we can do stack run to run that executable. You'll see now it's printing hello here. Okay, let's take a second to talk about the type of the print function. So print is going to take any A that's part of the show class, which is basically just means anything that can turn into a string, any type that can turn into a string. So all the default types are part of the show class, and any type you can create, I showed you this before, you can just put deriving show underneath it, and it'll be part of the show class. And it returns a IO and this empty thing. So an IO is, you can think of it as a special data constructor that you just never ever pull the value out of directly. And you can think of this empty tuple as just being the empty type, okay, in place of like, it doesn't have any other type associated with it, so we put this empty thing here. So when you think of print, in other languages you could think of it as like print returns nothing. But in Haskell, you can think of print as being print returns an IO value. So a very important thing we want to do with IO is we want to be able to sequence it. So we want to be able to say like print this out, then do this thing, then print this out, and then do this thing. So we want to be able to do things in an order, okay? We want to be able to say print this out at this time, then print this out at another time. However, like I've been explaining with lazy functions, usually things aren't evaluated this way. So to specify when you want to do something in order in Haskell, what you do is you use this do syntax, okay? So let's say we want to make a series of print statements and we want to make sure that they happen in order. What we do is we write do, and then we write each print one by one like this. Now you'll notice I put it in curly braces with semicolons, but you don't actually have to do that. If you just make sure they line up, you can get rid of the curly braces and the semicolons. Now, before we move on to explain more about IO, let's just talk about some more IO functions that you have for you. So in terms of output, the one I showed you right now is print, but there's also put str, just for put string. Okay, so this will take a string directly instead of calling show on it. It'll take a string and it'll output to IO, and it'll do it without a new line. So you'll notice whenever you put print, it automatically puts a new line. So if you put two print statements in a row, it'll automatically put them on different lines. But if you put multiple put str statements in a row, it won't. Then there's also the write and append files. So these are the file output functions here. So these write to a file. If you want to create a file and you have a string and you want to put that into the file, what you do is you specify the file path, and this file path type is actually just a string itself. So you just specify inside of a string the path to the file that you want to write, what you want to put in the file, and it'll write it out. You have your choice, write file, it'll create a new file, and if the file already exists, it'll just overwrite it. And append file, it assumes the file must already exist, otherwise it'll throw an error, and it won't overwrite it, it'll just add it to the end of the file. So let's explore some of these functions in VS Code. Let's say we're going to write a function print some stuff. Okay, and it's going to use print because they print some and print stuff. So you'll notice if we load this into GHCI, okay, and we want to print some stuff. It's going to put some and stuff each on its own separate line, and it's actually going to it's going to leave the quotations there, okay, because what it's actually doing is it's showing the string, which leaves quotations like that, okay. Now the other thing we could have done, this is a function I didn't quite show you, is put strln. So this means put string line is what it is an abbreviation for. And see if we load this. See, it does the same thing as string, but now it's actually not leaving in these quotations surrounding it. And then the other thing we might have wanted to do, you'll notice they're each on separate lines. It's maybe we wanted to put some, okay, but then we wanted to put stuff again on the same line. So what I could do is, instead of putting put strln, I'll just put str for this one, okay? And then I'll put a space in between because it's going to put it on the same line now. So if I do this and I reload, okay, so now these things are all on the same line. Okay, now what about those file functions? Okay, so I showed you two functions for working with files. Okay, make a file. So let's say I have a function and I want to create a new file. Write file. And what it's going to do is, you can even see right now, if I leave just write file, it's going to take, write file is going to take a file path and a string. Okay. So the file path is actually just a string itself. A file path is a type synonym. It's defined in the prelude as file path equals string. Okay, that's all there really is to it. So let's say we write just the name of a file. Let's say file.txt. And then I write some stuff. So I'm going to write some stuff now, not to standard output, but to a file, file.txt here. So if I write it just this way, and I reload, and run it, make a file, you'll notice it makes a file. We could actually go to the side here, where it shows all of the files in our project. You'll notice it makes a file right at the root of our project, file.txt here. And we can click on this file and look at it and see, oh yeah, it has some stuff inside it. Okay. Now, the other thing we could have done is actually specify a full file path. So this will be different depending on your system, and where you put your file project, right? So on Mac OS, a lot of systems, they begin like home, and then your username, and then something else, right? So you could specify a full file path to somewhere else on your system if you wanted to this way. And on Windows, it's going to be similar, but with a different, it's like users, your username, and so on and so on. For this class, okay, for what we're doing right now, I wouldn't really worry about that. I would just specify the file name and just put it to the beginning of your project. We'll never have to put a file right to a file somewhere differently. Now, you'll notice if I change this now, let's say I have write file, some stuff, and then I have write file, file.txt, some other stuff, okay, twice in a row like this, and I reload. And then I try and write make a file, and I go to file.txt. You'll notice it doesn't have some stuff and then some other stuff. It just overrode it as some other stuff. Okay? So, if I wanted to, instead of overwriting a file, append to a file, okay, add to a file, I would have to write append file. Okay? And now I save and reload that. Now if I write make a file, go to file.txt. Okay, so now it put both things. However, you'll notice that it kind of just left off. It kind of just started writing stuff out wherever the file left off last. Okay, so we wrote to the file and we wrote some stuff, and then when you write to the file next, some other stuff, it just immediately writes it right afterwards. What we probably would have wanted to do is put a new line in between these two things. Okay, so maybe we would have written to the file, and the last thing would have been a new line. And the way we do that is we just specify the new line character. Whoops, I deleted some stuff. So if you put /n, that'll be a new line character. And this way, if we run it, go back. Okay, see, now put it on separate lines. I also could have put the new line character, let's say, at the beginning of this string. Doesn't really matter. So those are functions for outputting stuff. What about input? So we have a few functions to work with here. One of them is getLine. So this will prompt the user to start entering stuff, and it'll end whenever the user hits a new line, so when they hit enter. Another is getChar. That'll get just a single character from the user. We won't be using this one that much. And another one, okay, finally, is readFile, which will read input from a file. It will read in all of these strings from a file that you specified. Okay, let's take a look at how these input functions are going to work. So imagine we want to write a function echo, okay? And what echo is going to do, echo is going to take user input, okay? Take some user input in and print it back out. Whatever the user inputs is going to print it back out. How would we go about doing this? So before I show you how to do this, let's, as an experiment, show you the wrong way of doing this, okay? So why would I show you this? Because this might be the most intuitive way somebody would think about using I/O if they didn't really know how I/O works. So the way you might think you would want to use it, just like looking at getLine, is you might say, well, you'd say let's say my line equals getLine in print line. Okay, this isn't what you think it is. Okay, it's not going to work the way you think it would work. So what's going on here? So getLine is an IO string. Okay, and when you say line equals getLine, guess what? Line is just also an IO string. Now print, it doesn't take an IO string. Print takes an A and returns an IO, right? So what we want is we don't want line to be an IO string. We want line to just be a string. Okay, so how do we do that? So there's special syntax for working with IO to do this. So what you do is we'll put this in a do, okay? So we start a do because we're going to want to do multiple IO things at once. And the first thing we do is we say line, and we use this arrow thing is getLine. And then the second IO thing we do, making sure everything lines up, is print line. Okay? So what's going on here now is getLine is an IO string, and line now is just a string. Okay? And then we're able to print it. Because line is just a string, we can print it. We can't print IO stuff, but we can print something we got from an IO thing. Okay? Once we turn it into just a string, then we can print it. So if we load this into GHCI to see how it works, okay, we'll say echo. You see, it's just waiting for you to enter something. So I'm going to enter something like hello and hit enter. And see, it prints hello back to me. Now let's try and do something similar with read file. So remember we had this file.txt from before that has some stuff and some other stuff inside it. And it's at the root of our project here. So let's say we want to echo file. Let's say we want to read that file in and then print it out. So what we can do is we could say do, and we're going to do basically the same thing. So if you look at read file, we give it the file path. So because it's at the root of our project, we can just write it, the name of the file. Okay. If it was somewhere else, we would have to write the full path to the file. So you'd have to do something like home/blah blah blah, whatever the full path was. Okay. But since it's at the root, we can just write the name of the file. And read file, okay, it also returns an IO string. So what we want to do is we want to take that string, okay, out of IO here. So to do that, once again, we're going to use that special syntax. I'm actually going to not call this line, but file contents. This is just a variable, so we could have called it whatever, but we're going to use this syntax, okay? So now this is going to, because this is an IO string, what this basically does is it's saying, get rid of the IO and just pull the value out. Okay, so for that, we need file contents. For that, we need this right here. Okay, so now that we have file contents, now we just print it back. Print file contents. Okay, and if we reload and run echo file, okay, you'll see it printed it out. Now you'll notice it printed it with this new line character. So this is another problem with the print function, is it's done quite literally. We can actually make this better by using put strln instead of the print. So it's printing the string, okay, correctly, and reload. Okay, and this is better. It prints some stuff and the new line, okay? It doesn't do it completely literally. So there are a lot of subtleties to how you use IO and do notation. So there's some things that we need to keep in mind while doing it. Every line of a do structure, so whenever you write do, every single line must return something of type IOA. And this arrow operator is your only way, if you have an IOA, to extract the A value. The last line, okay, of any IO function cannot use this operator. Okay, so you'll notice in the example I had before, whenever we read a file or some input, I would then do a print afterwards. I couldn't finish the function using this operator to pull something out. And any function that calls an IO function must also be an IO function. So there's never a scenario where you have a function that uses one of those functions like print or getLine or something, and it's not also of type IO, returning an IO type. To truly understand these subtleties, we need to consider what IO is as a data structure. But before we get into that, let's do a quick refresher on how data structures work. So we call the data structure maybe. That's a parameterized data structure. It takes an A value, and it's either going to be just A or nothing. Okay? And in order to use this type, this is a predefined type in Prelude, so we need to hide maybe and its constructors. So consider how maybe works, okay? Let's say we defined this function before, safehead, okay, that operates on a list. It pulls out the first element of the list, and it'll either be just X, or if it's the empty list, it'll return nothing. Now recall, this was the only good way. If we were to make head on a list of A, so a polymorphic list like this was the only good way to define this. Otherwise, we wouldn't know what to return for the empty list. Now say later on, we make some function add one to head. And this takes a list of int. We know it's a list of int now, okay? And returns an int. And what it's going to do is add one to head. It'll take this list and it'll be like, well, let's use the safehead function. And we'll pattern match on it and be like, well, when it's just something, then we'll return that something. When it's nothing, then we'll return 0. So now that we know that it's an int, we can return 0. Okay? So you'll notice with the maybe type, maybe is serving as like a wrapper. Okay? It's wrapping around. This just is wrapping around the actual value of A here. Okay? So we could also have written something like from just that takes a maybe A and returns the A. It just kind of pulls it. If you think of maybe, I just call it a wrapper. You could also call it like a box. If you think of maybe as like a box that you might put something into, you can take the just X and just pull it out. And then on the nothing case, in this case, maybe we'll just throw an error. Okay, so most data types, they're like this. You have the data type definition, and it's wrapping some value. And if you want, you can use pattern matching to pull out the value. Okay, pull it out of the box. Now, the IO type, it's IOA, and it has some definition here, okay? Now, how it's actually defined is complicated. We don't want to get into it. We don't need to get into it to fully understand IO. Okay. The thing to keep in mind here is you can never write a function from IO that takes an IOA and returns an A. You can never do this like we did with from just. Okay. You can never have this corresponding function. For one thing, so with maybe A, you know its value constructors. So just A and nothing, these are its value constructors, and you can pattern match on them to pull something out. With IOA, you don't know its value constructor, and this is on purpose. They're kind of hidden away. Okay? So this function is impossible. impossible. Rather, if you have the scenario, like let's say print string, okay, you have the scenario where you get a line, let's say from get line. Okay, so remember, get line is an IO string. And then we want to print that again. And then we print the line. Okay, so get line is an IO string. Let's delete this. It's an IO string here. Okay, list of char is the same thing as string. And then line becomes the list of char. It becomes string. So this is the only way to pull the value out of the IO box. Okay, just like with maybe we could do it using pattern matching. With IO, the only way to do it is with this thing right here. Now the trick here is that we're not allowed to end a do statement with something that's not an IO. So if I try and do this, like if I try and just return line, so if I try and write the function print string here, okay, that just returns a string and it uses an IO function, it just won't let me. It won't let me do that. Any IO function, anything that uses an IO function has to also be IO. Okay? And at this point, you're probably banging your head like, why? Why is this happening? Why can't I do this? Why are you being mean to me, Haskell? Why can't I just be like, yeah, I'm gonna have some function, it calls an IO string, and then it just returns a string. So the long story short of this is side effects. So remember I talked about side effects before? So side effects means that so Haskell has to have no side effects. Okay? So that means if I have a function f of x, okay, let's say equals x. If I have this function and I call it on 5, it's going to return 5. If I call it on 6, it's going to return 6, right? And there's never a scenario where I call it on 5 and then later on I call it on 5 again and return something different, right? But wait a minute. GetLine does that, and readFile does that. All of these IO functions, okay? You can call them with the same input. In the case of getLine, it doesn't even take an input, but with readFile, you can call it with the same input on the same file, and at different times it will return different things. So these functions, they have side effects, and it's like, how do you get around that? How can you read from a file and not have side effects, not have it return something differently? So the idea with Haskell here is, if you look, our main program is an IO. And the idea here is that no IO function ever returns a not an IO function. So all of your IO functions end up here, okay? So the idea here is that IO functions call pure functions. Pure functions never, ever call IO functions. So the idea here is that all of the IO functions kind of get stuffed into one spot at the beginning of your program, at the main program. Okay? That way, we've separated them. We've separated where these side effects can happen. So you'll notice we've gone way out of our way to figure out how to separate side effects. Okay? The Haskell has gone way out of its way to do that. And it, in a weird way, it argues still that it has no side effects because all of the side effects are kind of stuffed into the main program. Now, I'll just remind you, because you'll be wondering right now, like, man, is it really, why do we care so much about having pure functions? Well, having pure functions in your programming language is actually an amazing thing when you take the time to think about it. So first of all, the hardest part about programming, a lot of beginner programmers don't realize this, but really the hardest part about programming is testing your programs, is making sure your programs are working correctly. And guess what? it is way easier to test your programs when you know if you call it with this input, it is always going to give the same output. Okay, so there is a good reason. Haskell isn't doing this for completely no reason. There is a very, very good reason why we want all of our functions to be pure functions. Now we can argue about like if all of them really needs to be about pure functions. A lot of newer languages, what they're doing is they're like half functional and half imperative. And what they do is they encourage you to make as much functions as possible pure, and then sometimes you just have impure functions. But Haskell has gone way out of its way, and it's an interesting thing to learn about I/O and Haskell, just to learn how it was able to go way out of its way to make everything pure, or at least stuff all of the functions with side effects into kind of one segregated spot this way. So we can never take a IOA and just return an A in a function, but we can go the other way around. So in that example I had before where I wanted to get a line and I just wanted to return that string, okay? I can't return it just as a string, but I can return it as an IO string. So consider this function. This function will get 2 lines from the user and it will put them together. And maybe we want to modularize this as just one function, right? So we write this function, get 2 lines here. It gets 1 line, it gets another line. And now it can't just put the 2 lines together and return a string, but what it can do is it can put the 2 lines together and return it as an IO string by using return here. Okay, so what return is going to do is it's going to take just the string value and make it into an IO. And that way we have this one function for getting 2 lines that returns an IO value. This way we've made our own IO function this way. Now you can also use recursion with IO like this. So take, for example, a function that would essentially work like GHCI, like a read, eval, print loop. We call these REPLs, okay? And what it's going to do is it's going to read input, it's going to print that input, and then it's going to loop and just do the same thing over and over and over and over again. Okay, so this echo forever here would do this. And the way we would do it is with recursion. Now the question is, how would we make this function stop? I bet if you take a second to think about it, you could figure out a way. Now is also a good time to talk about the show function, just because it's useful with so many print functions that converts values into a string. So it needs to be a member of the show class to do it, but all of these standard Haskell types are members of show classes. And like I've shown you actually before, whenever you make a new data type, if you just put deriving show underneath that data type, it'll automatically make it part of the show class. So the idea here is, let's say we have a function add, all right, and we want to use this function and print out the resulting value. We would call show on it to first convert it into a string. And this is useful if you wanted to put it together with another string before printing it. The sort of opposite of the show function is the read function. So the read function is going to take a string and turn it into a value. Now, one of the tricks with the read function that you often run into is that you need to specify which type you want this A to be manually. So I've shown you how to do this before. You just kind of, let's say you have some function add strings here. So let's say you read some input, X and Y, they're 2 lines, okay? And you assume that these inputs are going to be integers. So you're just assuming that the user doesn't input anything that's not an int. And you call this function add strings, and this function add strings, it takes these 2 strings, and what it's going to do is it's going to convert them, okay? So if I wanted to convert just X manually, okay, I would say read X, and then I would have to specify using these double colons, like I do usually, the type for it, okay? Without these double colons, it wouldn't know what you want to read X as, Okay, so you have to do this. You have to specify the type. The one exception is if it could figure out the type from the output function, but a lot of the time it can't. So just do this to be safe. So this way, you know, you're taking a string and you're converting it into an int. Now, if somebody were to enter something with these functions that wasn't an int, like let's say x was actually a, the user just entered a, it would crash. Okay, so that is something to be aware of. Finally, two more functions just to be aware of that are often used with IO sorts of functions is lines and unlines. So a lot of the time when we read something from a file, you'll get the entire file contents as a single string, and that string will contain new line characters. And a lot of time what you want to do is you want to move through each line inside of that file. So to do that, what you do is you would call the function lines on that string, and it would separate that string into a list of strings based on the new line characters. Okay, so whenever it sees a new line character, it would break them up and it would make them into separate strings. And the inverse of this function would be the unlines function that takes a list of strings and turns them into one big string with a new line character. So this would be useful if you wanted to read a file in, okay, iterate over that file, okay, iterate over each line of that file and do something, and then write that file back out to another file. You would lines the initial input, and then after you're done doing your thing, you would unlines it again into one string, because write file only takes one string, not a list of strings. Now, before we finish off, I just want to summarize what I was talking about with IO before. So the idea with IO is that you separate pure functions from IO functions that could contain side effects. So the idea here is that your program, it starts with a main program that does IO stuff, and you want to put all of your IO related code together there, and then your IO related code will call the pure functions. Now, you can still do some work where you end up kind of mixing your pure functions with your IO functions. So this is some example of what I would consider some very badly formed Haskell code. So the idea here is this takes input, okay, and it assumes that input to be integers, and it adds them together, and it prints out the result of that add. So it's doing this by, it's getting the input, and then it's doing the work to turn that input into an integer, and then doing some work to get the next input, turn that input into an integer as well, then adding these two things together, then returning the results, and then printing the result. Okay, so this is, I would say this is very bad Haskell code. What you want to do is you want to kind of separate these two things out. So you look and you say, okay, what is the code that I need to be doing? I need to get the input. Okay, so there's two inputs here. So I need to get these two inputs, and then I need to print them out. Okay, so I want to focus my function, that's the IO function, on only doing these things. And then what I do is I call the pure function, add strings, that'll do the work, all the other non-IO work. So this is going to include stuff like using read to turn those strings into integers and doing the actual addition. So that's all we need to know about IO for this course. If you go looking around in the literature online, I should mention before we finish, you will find out that IO is something called a monad. This is out of the scope of this course. It's something that throws a lot of people off when they're learning Haskell because they think it's a more complicated concept than it really is. I would try and ignore that for now. Just focus on learning what IO is on its own. With that, take it easy, guys. See you next time.